Okay, welcome to class. I'm fighting with the microphone today, so please ignore me. We're going to talk a little bit about storage options for Windows Server. We're going to talk about disk management, RAID, and how to back it up. What's the difference between a basic disk and a dynamic disk? James.
I'm still thinking about everything else, but
What's the difference between a basic disk and a dynamic disk?
partitioning, isn't it?
Essentially. Basic disk uses traditional of everything. Dynamic, you can change it, the scope of you can shrink it or expand your partitions. With basic, what you see is what you get. Okay, you say 40 gigs, it can't be changed. You have to delete it, break it apart to add back to it. Partitioning, basically all it does is it gives you a chunk of pie and you take out 1/8 of it. That's a partition. All right. Formatting, everyone understands what a format is, right? It takes away your headers on the top of each table, or creates the table full of headers that point to where the locations of the different parts of the file or folder or anything that is. Volume is the logical designation of the disk. It says if you have something that's on multiple disks. It says volume 1, volume 2, volume 3, things of that nature. Basic disk have 3 different types of RAID. RAID 0, 1, and 5. Okay. It can be used on the primary partition of it or an extended partition. How many times, when y'all were going through your labs and you were formatting your disks, right? You understand the basic and the extended, correct? Okay. RAID 0 is striping. RAID 1 is mirror. You know how I remember mirror? If you put 1, just put your finger up. You're looking in the mirror, right? I'm looking right at it. Kind of remember it as a mirror, or the side of a mirror. All right. And then striping with parity is RAID 5, which means it has a parity bit. So if you have if you have the 3 disks, you have your A, B. You write on A, write on B. Parity bits on C. Write on B, write on C. Parity is on A. Write on C, write on A. Parity is on B. Make sense? RAID stands for a redundant array of independent disks. Means you have to have 3 separate physical drives if you're going to do a RAID 5 or RAID 0. To do RAID 1, you have to have 2. Okay? What is an MBR or in GPT? Cameron, what's MBR?
Master boot record.
The master boot record. What is it? What is it for?
I believe the computer looks at it when it needs to boot. The computer looks at it when it needs to boot, and then it'll tell it where to go after that.
Okay, what a master boot record is. All it is, just think of a little Excel table. It says, here are my hard drives. I have A, B, C, or partition C, B, or C, D, E, F, and G. My active partition in which my operating system may be on may be G. So that master boot record will point. If I need to boot, I go to G. It just tells you where that active partition is. That's all the master boot record does. It logically lists out where every drive is. And it is located on the first sector and the first track of the first hard drive. It's the first thing that after the power on self test when it's going through, and it reads it to see if there's an operating system there. When it says NT loader missing, corruptor missing or not found, it's because it's not seeing it in the table. All right.
It's not saying an operating system, you mean?
Yes.
Or somewhere to go?
Yeah. All it's doing is finding where your operating system is going to be on an active partition. Okay. So the table, you may have 5 lines and say C, D, E, F, and G. But if my active partition with Windows operating system is on the G drive instead of the C drive, which is C is by default anyway. But if I say put it on the G drive, master boot record will boot to that G drive to boot the operating system. But the master boot record is actually physically located on the first drive. first tracking sector of it. Then we have the GUID partition table. Basically, this is the it's a newer version of the master boot record. And all it does is it helps you partition disk, and because master boot record you could only have a couple partitions. The GUID gives you a lot more flexibility. Think of it as dynamic versus master boot record being basic. Does that make sense? Primary and extended partitions on the master boot record disk. The primary partition, or the active partition, is the one that you boot from. You have to have at least one primary partition / active partition on your system in order to boot into an operating system. That's why it comes up with NT loader missing or not found, no operating system found. Those are what you get. Like I said, the active partition is where your computer would look for the hardware-specific files to start the operating system. Okay, primary and extended partitions on the master boot record. An extended partition is the partitions that is not yet formatted or allocated. Okay, doesn't have partitions on them. It's just extra hard drive space. Let's say you have a terabyte hard drive. When you first create it, I only take up 100 gig for my C drive. The rest of it is what we call an extended partition. After the operating system is installed, the rest of it's extended. All right. You can your basic disk, your master boot record allowed you to have 4 partitions. Extended disk lets you have a lot more than that. So that's more your GUID type. So here's what you can have. Disk 0, you can have your NTF partition, programs, documents, and users, right? C, D, E, F. And then on disk 1, you can put G and H. You've extended that partitioning. Which I've already done those. Volume and stripe sets. What's a volume set? A volume set may be like if I have 3 drives that are each 60 gig. If I put them all into a volume, now it looks like I have one 180 gig drive. So you're familiar with SAN storage area networks, where they may have like 1,000 terabyte drives. Okay, so they have a petabyte. So your system would recognize it as a petabyte of data, because they're all one volume. It's a lot of data. A stripe set. Basically, you have to have 2 or 3, depending on what RAID level you're going to do. All right. Now, one thing about stripe set, it does not increase if you have 360 gigs, where if you did it with volume, you're seeing 180 gigs. With the stripe set, you still only get 60 gigs, but you have 3 drives, because it's putting it over the 3 drives. You don't fill it up as fast because you really are putting it over 180 gigs, but you only see 60 gigs. Does that make sense? Now, a dynamic disk, what is it? It allows you to set up a large number of volumes. Think SAN, okay? And you can extend this volume over multiple physical disks. One span volume, though, is limited to only 32 disks. So in my example, when I said you have 1,000 terabyte drives, you would have actually multiple volumes. But you can go up to 32 terabytes. Well, now you have 4 terabyte, 8 terabyte drives, and of course it'll go up higher than that. But that's how you do it. Get a 100 terabyte drive, and 32 of them. Now you have 32 petabytes, right? Or 3.2 petabytes. Simple volume versus spanned volume. A simple volume, a portion of the disk or the entire disk itself can be a dynamic disk. which means it can fluctuate. Span volume, you have 2 to 32 disks to create your volume. Excuse me. But they're all treated as one. Make sense? So there's an example of a 380 gig span drive. Stripe volumes are referred to as RAID 0. You spread data over 2 or more drives. RAID 0 you actually use 3. So this is how you do it. It makes sense. So instead of having, what is that, 12, instead of having 12 rows on that one disk, you've now put it over starting in the third row. Shrinking of volume. This is a feature that came out in Vista in 2008, where it takes your, let's say you have, you over formatted your drive and said, I had 100 gigs for my operating system. Do I need 100 gigs for just an operating system? No, let's shrink it down to, we'll shrink it down to 40. And that gives me 60 more gigs I can use elsewhere. That's all it does. Use it with a shrinking tool. Under disk management, provides basically a location for you to do all your disk management features. Y'all did the partitioning, correct? How many of y'all have done your assignment?
I thought we were supposed to wait till this week.
Okay. I didn't know if any of y'all had started on it. That's why I was asking.
I remember Amanda asking you about that last.
Partitioning in simple volumes. Partitions operate as a separate storage unit on a hard disk. Right? Basically, they're just buckets. Now, you can create new ones by just creating the simple volume and going through the wizard and doing that. Mounting a drive. How many of y'all had Unix Linux before? So you understand the term mounting, other than Anthony.
You have to make like your own little, what was it called? What was
Well, the mount, yeah. Basically, you're mounting a drive when you create the drive. Windows makes it easy for you, so you don't have to go do it like you do on Unix or Linux. Home directory, home folders. Basically, just something you can use for user accounts to store information in. Not that big of a deal. It's just like a new folder on your desktop. Disk defragmenter, basically all it does is over time your disk is going to become fragmented. Files are not going to be sequential in order. Remember, files when you first start at the very first bit that's available until they fill that up and they go to the next bit that's available. So that's why your header tables, if you notice your slow performance on your hard drive, it's because it's having to find them throughout all the sections. That's why disk defragmentation came into play. Disk check allows you to scan your disk to make sure you don't have any bad sectors. How many of y'all have ever had RAM reference errors saying, hey, you can't get to this because you have a bad memory or bad sectors? You can run check disk, CHK, DSK. And what that does is it goes in there, tells you, hey, we got so many bad sectors on the hard drive. Usually after about 10% of the hard drive is affected, just throw it away, because it's going to become useless after that. Check disk will allow you to fix some errors if it can. If it can't, then you're just going to have bad sectors on your drive. And you don't want bad sectors on your drive because inevitably Word is going to put one in those bad sectors, and then you're screwed. And it's your 50-page report for my class, and then you can't get to it. You spent 13 days working on it straight like Cameron would, and then all of a sudden it won't open. And you can't email it to me.
By now I've learned to save in multiple locations.
Fault tolerance. Basically, it's the ability of the system to gracefully recover from a hardware or software failure. How fault tolerant are you? Well, when you think of fault tolerance, you usually think of mesh networks and network security, fundamentals of networks, right? Building that mesh. so that if one segment goes down, you can still get to it via another path, right? Just like you do in intro to routing, you want to have multiple segments going to each router so that you can still complete your tasks. Windows 2K8 provides that level of fault tolerance through what they call software-based RAID that allows you with over the different volumes and spanning and striping and things of that nature. That's really all it amounts to. RAID volumes, basically, again, for the third time this time we're talking about RAID. RAID 0 has no redundancy. Okay? That's why they call it RAID level 0. 0 means no redundancy. Why would you want to use it? Because all you're doing is, if you have a bad disk, there's no way that it's going to be able to bring it back together. That's why there's no redundant. That's why RAID 5 came out striping with parity. That parity bit can help you rebuild your drives. That's why you have to have 3 drives with RAID 5 or higher. Okay? RAID 1, disk mirroring. Now, it provides you fault tolerance provided one of the 2 drives doesn't go down. If one goes down, you can copy it from the other. But if both of them go down, you're screwed. With RAID 5, here you go. Disk mirroring, you have the mirror drive, the primary drive, and you have that adapter. Disk duplexing, which is your... you do it on one, then it copies it to the other. I like the disk duplexing better than I do the mirror drive. RAID 2. Then you have RAID striped across all disks. Okay. RAID 3, it has striping, but with error correction. They were starting to get a little bit better. Okay. RAID 4, it stripes the data and stores the error information on each drive. Now you can see how that bandwidth, or your space, is going to get really limited really quick, right? So that's why you don't. RAID 3, they were only taking that error correction and just putting it on one. Then they came up with, let's use parity. And parity puts the error correction, checks some value to make sure that you have your 3 drives. If you got it on A and B, in case B fails, you can rebuild B. Does that make sense?
Question.
Yes.
In the real world, how often are these drives tested for like their longevity or like fail rate?
Depends on your company and depends on the policies. If you're someone that has
That's what I would guess.
a high-end database and you back it up every day, you may test it at least once a week just to validate it.
Like Google or something?
Yes, they test it every day. But if it's someone like a mom and pop shop, you could probably go a year without testing. Okay. So it really just depends on the level of the use, and the more you get into enterprise data centers, you're going to be watching a lot more carefully because you're going to have a lot more failed drives and a lot more things you have to do. Remember, the bigger the scope, the bigger the microscope. Does that make sense? I always like that analogy. The bigger the scope of what you're doing, the bigger the microscope. Because you're going to have more people watching you because it's going to be more important.
And more drives, there's
More chances of failures. You know, you put 30 people in a server room, what's the likelihood something's going to happen compared to one person? Well, you're going to have a lot more body heat, which is going to raise all the temperature in the room. You can have hardware failure. What about static electricity? And there's a lot of things to think about. Why would you want to use a striped volume? Well, striping makes sure that you don't use the same drive over and over and over and over and over. The read-write heads are not continuously running across. That's how you get bad sectors, especially if it gets bumped. Mirrored basically just creates a mirror copy of it. It's basically a full backup. And then fault tolerance is best with RAID 5 because it stripes over multiple volumes and the data keeps moving over the volumes. And the parity is true, false, or 1-0 logic. So basically, you'd have your parity, you'd have your 5, hit another parity, have 5 more, hit another parity, have 5 more. That's what I was explaining earlier. I just used an example of 5 instead of 3. Mirroring's a lot faster than striping, because striping has to take it and break it apart and put it over different hard drives, where mirroring can write at the exact same time because it's doing the exact same thing. Basically, software RAID, it works through the operating system to create its fault tolerance. That's really all you need to know about software RAID. It allows you to do hot swap. I'm not going to worry about SANs. We already talked a little bit about them and how they stretch over multiple volumes. Basically, a SAN is its own subnet. And it's either working on Fiber Channel or SCSI technologies. Logical unit number to the LUNs. Basically, that's the identifier of the SCSI. Remember, SCSI can be only in a chain of 7, right? Y'all remember that? How many of y'all remember that? You only put 7 SCSIs in the same chain. That's its max.
Who deals with SCSI? Yeah, I think that answers your question.
But doesn't it support, like it has a target ID of 15 or something like that?
Yeah, because you can have your original IDE cable that goes into your SCSIs cards. You have 2 different inputs. So one will be on the 7 and one will be on the 7, and the SCSI card itself is 1.
Is SCSI even used anymore?
Yes, it is.
I think I saw,
The servers that are in my office are 80-pin SCSIs.
I've seen it like once, like when I was at Moore Norman Technology Center, and that was it. And that wasn't even because of the curriculum, it's because I wanted to. I've never seen it.
Go look at the servers that are in my office. They're 80-pin SCSIs. Oh,
Is
Ultra
it
320.
Old school technology though?
It's older.
Okay.
You're on eSATA and SATA now.
Well, yeah, that's what I was like, am I?
Again, this is 2008, not 2012.
So the only thing knowing about SCSI is
Yep. Make sure you don't put 6 and 6. Then it doesn't like it too well. Oh, you also have to put on your end, because if you don't put the end on the, basically there's a ribbon cable, and if you don't put the end connector on there, the terminator, it sees it as infinite, and that whole SCSI chain's down. That's what I hated about SCSI, because you put it on, but it may not get all the way done. Then you anyway. Multipath input output basically just gives you multipaths to the server for disk storage. Device specific modules, we don't even use those anymore. Disk backup, how often do you want to back up? Again, depends on the scope. Would you want to do it network backup or hardware backup? Hardware meaning physical drive to physical drive. No, I would want to do backup, network backup, and send it out over my fiber to an offsite location, so I don't have to worry about it. Because if you do it backup locally to either a tape or another hard drive, someone has to physically take it off every day. And if they're smart, they build one at home and download your data. And I'm sorry, I'm mean. Volume Shadow Copy Service, or VSS, basically it allows you to do your backups on your server. How many of y'all have ever talked about the backups? You know how the backups are? Full, incremental, differential.
those are the internet networks.
Okay, full basically it's everything in its mother. Doesn't matter whether the archive bit is set or not. Incremental it only updates or only backs up the files that have been updated. Custom backup, I don't know why they didn't put differential on here. Differential is basically what has been done since the last one.
What's the difference between that and
Okay,
incremental?
Differential is everything since the last backup.
Oh,
So all it does, a full backup will copy everything. Differential will only copy everything that was been changed since that last backup. Incremental will only copy things that have been updated. So that's the difference between incremental and differential. Differential will copy everything that, even though if it wasn't updated, it'll still copy over since that last full backup. Custom backups, you can change them around, set up features, things like that. Yes, we know backup has scheduling capability because I just talked about it. If you want to do backup schedule, you can do full server. You can set the time, the day, more than once a day. I have yet to ever see anyone that does it more than once a day. Maybe Google, but remember, if you do this, you've got 2 simultaneous transactions going. What's currently being worked on your network plus the backup. So you already degraded your performance by 50% when you start doing this. So that's why you do it like 2 o'clock in the morning when no one's on your network. And you can do it these different ways. Performing recovery, file folder. I mean, with backup, you just tell it to recover and it brings everything back from the last backup you have. Performing recovery, you got to go back to the last full backup you did, back it up, and then do your incrementals in order. That's where it saves to be differential, because then you start doing differentials, and then you don't have to worry about those incrementals. Any questions on those? Other than Cameron going to sleep. You okay? Pretty easy chapter, right? Managing Windows Network Services. You're really ready to go to sleep, aren't you? We're talking about install, configure DNS, WINS, DHCP, and IIS. What is DNS? Basically, it's a domain name service. It takes your IP address, converts it to, or takes your domain name that you put into your web browser, converts it to an IP address, and goes out. Installing DNS, you go up to the roles, install DNS. But since you already all have Active Directory, you already have DNS installed. Okay. DNS zones. The areas that are, or partitions that are associated with DNS are called zones. You have a forward lookup zone. What it does is it links the computer names, or the domain names, to an IP address. So if I wanted Brittany's phone number, or if I had a table that says Brittany's name and Brittany's phone number, and I'm going down and I'm trying to find her contact information, I click Brittany, what's the next thing that comes up? Her phone number, right? Just on your phone. Same idea. That's what a DNS is. You remember names better than you remember numbers. Humans are programmed that way. That's what a forward lookup zone is. You're taking that information you know, and it goes through and gives you the other. What we call that record, or that phone record, is called a host record or an A record. Now, if it's an IPv6 address, let me put IPv4 is an A. Okay, so her name would have been an A, because her phone number was an IPv4 address. But if it's an IPv6, it'll be a quadruple A. Make sense? And those are called resource records or host records. Basically, it just goes through. You have canoquial names, which is your DNS name or your C name. Mail exchanger would be MX. Your name server is NS. Pointer record. I mean, these are just the types of resource records you can use in a DNS. A reverse. Let's say I have the IP address, but I don't know what the canoquial name is. It'll tell me what the canoquial name is. I can manually create a host record. Let's say if I created my own website, I just have my new DNS, but it hasn't been updated and replicated out to Google and everyone else. I can add it onto Cox DNS, just telling them, hey, here's an A record, here's the name, and here's the IP address. That's what Dynamic DNS does. Everything that you do through Dynamic DNS is all host records. Microsoft DNS is also called Dynamic DNS. Basically, it allows client computers to automatically register that IP address to DNS. It's replicated everywhere. That's why Dynamic DNS is so much fun, because you can bypass Cox, because Cox doesn't like you doing it unless you're a business. DNS Dynamic Update Protocol comes along with that. DNS replication, you have a primary DNS server. That's going to be your main administrative server. That's where you put all your host records. That's where you put all your information in. Your secondary DNS record is not authoritative, means it doesn't have any authority to do anything. All it is just like your phone book on your table. Okay, that phone book on the table can't call anyone, can it? But your phone can. So that's the difference between the two. Vital services for DNS replication is to make sure that the DNS table is replicated correctly to the non-authoritative or the secondary zones, or secondary DNSs. Now we have what we call a stub zone. It is somewhat authoritative, but all it does is allow you to find those authoritative. It gives you very little authoritative rules. All right. If I had, for example, Microsoft.com has a authoritative DNS server. If I'm technet.microsoft.com, I may be a stub zone. So anything that's underneath technet, I can point right back to that, which will forward it back to the original DNS server. Does that make sense? And that also means it doesn't have to go outside the network to resolve a host to come back in. It'd be like having a stub zone in this room can resolve anyone's computer name in this room without having to go over to 201 or over to IT to resolve it to come back. Does that make sense? And basically, this is all it is. You have a DNS server at West College. It's trying to get information to the commission network. It forwards it to the next DNS server, which forwards it again and forwards it again until it finally reaches that DNS server that it needs to on the commission network. You can read about the DNS implementation plan. About 90% of the time, you can have a DNS just for your own host record, and it's going to be pointing to a DNS outside of your network. So you really don't have to have an implementation plan. DNS server can be housed on a read-only domain controller, so that if you have, y'all know what a read-only domain controller is. We covered that earlier. The read-only or the RODC could be at your Tokyo office, so that it can give all the hosts, basically be acting like a stub zone at your Tokyo office to make sure that everyone can resolve their names quickly without having to come all the way back to the U.S., get authority, and then go all the way back. Does that make sense? Wins. Basically, this was what happened before you had DNS. It was a Windows Internet Naming System or service. Basically, it just took your computer's NetBIOS name and applied it to an IP address. How many of you are familiar with the host file that we showed you earlier this semester? That's what Wins is about. That's where it would look at. That's why it always goes to that first to see if there's anything there before it goes over to a DNS server. Kind of makes sense now? Y'all kind of seeing this picture starting to develop of how things flow? Cole? You starting to see how it flows? No, he's asleep. Okay. DHCP. What is DHCP? It gives you an IP address automatically, right? That's pretty much all you need to know about DHCP. It provides you an IP address. Now you can have different scopes. I think it's up to 1,000 scopes in 2K8. But in each one of those scopes, you can have tons of clients. Okay. What that does is it allows you to be able to distinguish or subnet your network into the way you need to do it or way you want to do it. Also provides IP addresses to those local machines. Otherwise, they would not have connectivity. They would have a 169 address, right? The non-routable address. Once the DHCP server is there and gets a host name inside your network, it automatically updates DNS, which forwards it out to the stub zones and everything, so you can figure out which computer's which. Just by typing, like if you type localhost in a web browser, if you have IIS running, then it'll take you to that local web browser, because what is localhost? 127.0.0.1, right? Well, it's going to point to there. That's in your local web host folder. But let's say I want to go to Jackson's. If I can just say Jackson. If his has already been registered through DHCP back to the DNS, I can type in Jackson and go right to Jackson. You can do scopes and reserve IP addresses for certain objects. What I like to do is I have wired, or I have 5 different areas of scopes that I do. I have reserve scope for wireless, reserve scope for wired, reserve scope for the company personal internal network, and then I have 2 DHCP networks. So it kind of keeps them all blanketly different, so you can't cross IPs. DHCP doesn't take very long to do. It's another role. You're going to start configuring DHCP scopes. Now, when you start installing DHCP and DNS, do not. You can install them, but then you need to disable them, because you will take down VM.
I've done that before.
All right. I'll remind you, but if I catch you leaving it on, guess who's going to get? Cameron's going to get the grunt of it. Like Ken was working today on it. How frustrated was he today?
He wasn't, he didn't sound too happy.
Yeah, because it took down the VM server. Then you authorize it. After you install your scopes and everything, then you authorize it. At that point, just don't authorize it. Just let it be. Or you can authorize it and then disable it, so I can still see that you did it. All right. You can also do DHCP version 6, which allows you to do DHCP for IPv6. Don't mess with it. IIS. How many are my security comm? Anthony, Cameron, you in there?
Summer.
Anyone else in there? Just Anthony? IIS is Microsoft's web server that's built into any operating system after XP. It allows you to offer a complete website with functionality with authentication, NTFS permissions for people to get into your systems. ISAPI, which is the Internet Server Application Programming Interface, basically it allows you to do some extra features and stuff. You can do ISAPI filters and prevent people from doing certain things too. IIS gives you 3 options. You have your web server, which is your wwws or HTTP protocol, your FTP protocol, your file transfer protocol, and then your SMTP, which is your mail protocol. When you install IIS, you can do all that. Basically, 2K8 is a good candidate for a web server because it has everything that you need all in one box. Even though it is very expensive to run just a web server on 2K8, I'd rather, if I'm just going to do a web server, I'd just do Apache. Because it's free. Everyone likes free. IIS is newly designed for 2K8. Yeah, it was IIS 6, which is a piece of junk. Or 7's even worse. I liked IIS 5. It's easier to manipulate. IIS, you can go through a tool. You manage, make it ASP pages, ASPX pages, .NET pages. You can do all sorts of things. And your manager allows you to change all the authentication, protocols, directory browsing. You can edit who can see what, who can do what. change your default pages. You can do, there's just a ton of things you can do. But here's IIS Manager 6. You can create virtual directories, which are always cool, especially if you want to do file sharing with your friends. Create your web page, do the DNS entry, so they can just go to Brittany.org, and when they go to Brittany.org, and give them virtual directory. I used to do that with all my hacking tools, so people could just go and download them for free. Don't have it anymore. But
Okay.
I will have websites where I actually put like a little dot somewhere, little small, a hyperreference to a virtual directory page. Little goose egg. I forget what they call them now. Easter eggs. Should know that. Easter's this weekend. You click on a little Easter egg, it'll give me my virtual page, and then I can download anything I need to from my box. I should tell you how to go find one. All right. Basically, you can do all sorts of things. You can create your own certificate. I highly would encourage you not to create your own certificate. Go to VeriSign or somewhere like that, so they can authenticate who you are. Because otherwise you can get that non-trusted certificate thing that pops up and annoys everyone. SMTP email page, basically you can send email directly out of your system. This is always fun once you create it. Web forms, you can send out webmail with it. That's SMTP. Cox doesn't care. You can make it johndoe@whitehouse.gov and type an email and send it out to a spam list, because it's coming from HTTP. It's not coming from your internal port 25. Voila. That's how spammers do it. Didn't know that, did you? They don't go to Outlook and open it up and dump in an Excel file. They program the website to read this Excel file, and it just keeps sending messages to you. That's all it is. And then if you ever unsubscribe, then they put you on there like 6 times because they realize it's a true email address.
Oh,
Yeah.
nice.
But anyway, that's where you go in to do that. Not worry about troubleshooting. Is there any questions, items, concerns, gripes, commands, complaints? I know I bored you to death with 2 chapters tonight, but every Tuesday night it's going to be 2 chapters now from here on out. 9, 10, and 11, and 12. There's only 2 more lecture nights. Isn't that nice?
We're almost there.
Is this better than what the semester started off to be?
Yeah, we're here.